So today we're going to look at the graph of tan theta and eventually cotangent as well. But the thing we have to, or you might have seen the sketch of tan last year, but we didn't have to necessarily have to draw it. This year we'll have to draw it. But the big thing we got to remember is the connection between sine and cos and tan. And one of the big identities we had last year is that tan theta is equal to sine theta over cos theta. So that's really important when knowing about tan, is that tan is equal to sine over cos. So if we were to sketch tangent, we should know what all of the trig ratios are for sine and cos. So very quickly, I'm going to get these. Now you already have this from other investigations, so I'll just write them down quickly. And I'll just do a few there. Cosine starts at 1, and it goes down to 0.866, 0.707. Sorry, this one here is 0.707. That's 767, 707. And then 0.5, and then down to 0. And then it starts going further down into the negatives. So if we're going to graph the tangent, what we want to do is take the sine over the cos. So the first one at 0 degrees, sine is 0, cos is 1, so 0 over 1 is just 0. And then at 30 degrees, we would take 0.5, divided it by 0.866, and we would get that it's 0.577. Next one, at 45, it's sine over cos. Well, they're the same, so 0.707 divided by 0.707 is 1. And then 0.866 divided by 0.5 is 1.732. And we see a certain shape starting to take pattern until we get to this very unique one at 90. And at 90, it is sine over cos, so that's 1 over 0. Are we allowed to divide by 0? No. Which means tan doesn't have an answer at 90 degrees. If you punch that in your calculator, you actually see you get an error. In the graph, you can't divide by 0. What happens when you divide by 0? In the graph, you're going to end up with an asymptote. So very different sketch here when we're talking about tangent. As opposed to sine and cos that were continuous all along and just repeating. Tangent will have these breaks and they'll have these asymptotes. So I'm just going to start sketching these first few points. And I'm going to start by sketching the asymptote. And it's at 90 degrees, which is pi over 2. So right here, there is the asymptote at pi over 2. Now I'll start sketching some of the other numbers. I'm going to work at 0. It's 0. Okay, good. So that's an important spot. And then at 30 degrees, which is right here, 30 degrees, is right here, and 0.567 is roughly there. 45 degrees is going to be halfway between 30 and 60. Like this is 30, 60, 90. So halfway between 30 and 60 is 45, and that one is at 1. And then 60 degrees is at 1.7 up here. And then what you should know is that the graph is going to keep getting bigger and bigger because as the sine values get bigger, the cosine values get smaller, the tangent is going to go off like this. We have that shape. Now we hit our asymptote, and now we're looking at the other side of the graph, and notice that sine stays positive here, but cosine becomes negative. So the numbers are still going to be the same. It's still 0.866 divided by 0.5, except it's divided by negative 0.5, which means this is going to be negative 1.732. And so that first tick here is going to be down at negative 1.72. And then it'll go to negative 1, and then negative 0.577, which is roughly here. And then we're going to get to this special spot, which I'm going to talk about in a moment. But the graph is going to start doing this. Now, if you follow the graph, it looks like it's going to touch 0. So we could make a prediction that this spot right here is going to be 0. Let's actually find out. Well, if we were to do the sine is at 180 is 0. And the cosine is negative 1. And so no problem, we have 0 divided by negative 1. That's okay. That is 0. So indeed it is 0. So it does come up here. And then what you're going to see, it's going to repeat. And I'll let you fill in this column on your own time to see that it does in fact repeat in the same spot. So it'll be here, and then 0.5, and then 0.707, and we'll have this graph like that until we get to our next special spot, which is going to be an asymptote here again. And so the graph will go off like that. And then it'll repeat. And we'll have this spot, and this spot, and this spot, and it'll go like that. And it'll keep going on. But that technically is one cycle from 0 to 2 pi. You should know, though, that the graph is going to continue on and do this with another asymptote, and another asymptote, and it repeats. And another asymptote, and it repeats. And this is the shape of tan. But just the first part from 0 to 2 pi is probably what I would ask you to sketch. Now, if we were looking at cotangent, we would recognize that cotangent is just the reciprocal of tan. So cotangent is 1 over tan. So if I took all the tan values and did 1 over tan, then we would have those as well. So here are all the tan values: 0, 0.577, 1, 1.732, and then an asymptote there. So cotangent, we would, if this is 0, and we flipped it and did 1 divided by 0, well, that's obviously not going to work. So there's going to be an asymptote there. And if we had this would be 1 divided by 0.577. And 1 divided by 0.577 is 1.732. Now that shouldn't be too much of a surprise, because if we look back to cotangent, if tangent is sine over cos, then cotangent is cos over sine. So if you went back and looked at 30 degrees, at 30 degrees right here, you would see that for tan it was sine over cos, but if we're going to do cos, we would do cos over sine. So it would be 0.86 divided by 0.5, which is exactly the same as this number, which is why you end up with 1.732 in the other one. So it's not a surprise then. This is 1 over 1, which of course is 1. So the cotangent and tangent at 45 are the same. And then this is going to be 0.577, because again, you reciprocate, this would be 1 over 1.732. You can check that that's 0.577, or you can do that it's cos over sine. And then the trick here is, In tan, it's an asymptote, so how could you do the reciprocal of an asymptote? Well, again, let's go back to this definition of cotangent, is cosine over sine. If we went back and looked at 90 degrees, it would be cosine, which is 0, over sine, which is 1. And that is okay, that's 0. So this actually gets you a 0 point. So now if we were to do some sketches for cotangent, the cotangent has asymptotes at 0. I'll just move that over so I have a better drawing. There. And so it's at 0, and then there's going to be another one at pi, and another one at 2 pi. So the asymptotes are going to be here, here, and here. And I'll let you fill in these columns to discover that as well. Now if I actually sketch them, 30 degrees is right here, and 1.732, so it's right there. 45 and 1, 60 and 0.577, and then 0. And then I'll let you fill in these charts to convince yourself that indeed it goes like this and follows the same pattern down here. And it's going to repeat. So now the last interesting part of this is the connection between this graph here, the cotangent, and the tangent, and how they're reciprocals of each other. So what I've done is I've taken a photo of this and brought it over to our other screen here, and then we can look at the comparison between the two. So now I have the tan on the top and the cotangent on the bottom. And you can start to see the connections between these. So the first thing that I notice is when tangent is 0 and you flip 0 and make it 1 over 0, it doesn't work. So where tan is 0, you end up with the asymptote at cotangent. There's all the spots where it's 0. Look, asymptote, 0, asymptote. And the opposite is true. The reason this is an asymptote here is because it's technically 1 over 0. But if you flip that, take the reciprocal of that, you get 0 over 1, which is okay. And that's why this asymptote actually ends up being a 0 here. Same with this asymptote is 1 over 0, which doesn't work, but 0 over 1 is okay, and that's why that works. The other spots that are common are 1, so the tan at 45 is 1, and the cotangent at 45 is 1. Those are the same because 1 over 1 flipped is still 1 over 1. Same with negative 1 right here and here, and you see it repeating at 1 and negative 1. All the spots all repeat. So those are all common, and then of course this part of the graph is really, really small numbers, and when you take a small number and flip it, it becomes a very big number. And then these keep getting bigger and bigger, but if you flip it, these get smaller and smaller and smaller. And then vice versa, we're down in the negatives. This is a negative big number, but when you flip a negative big number, you end up with a negative small number. And then these numbers get bigger, but in the negative, and these get smaller, excuse me, in the negative, so the reciprocal is going to get bigger. We end up with that same shape. So it's interesting to understand the connection between the two as well. So there's your sketch of tangent and your sketch of cotangent.